All right, here we go. We're going to finish up the second example problem, parts 3 and 4. Let's see, what do we got? We drew the free body diagrams. We figured out the tension of the string. Now the third part is they're asking about the force of friction acting on the 5-kilogram mass. Well, if you know the force of tension, right, same rope, same tension. The force of tension here was 39 newtons, so the force of tension there is 39 newtons. Now you go back to your free body diagram of that box. Some of the forces horizontally in the x direction. This is getting a little crazy, so I'm going to redraw all of this. Okay, so if we come back down here and we have a 5-kilogram mass and the tension in the string was 39.2 newtons and it's at rest because there's a force to the pulling it to the right and it's not moving. There's got to be a force to the left. We figured out also, we know that there's gravity down and the normal force supporting it up. We figured out that this was 49 newtons and this is 49 newtons. That's all from the last video. So here, if you do sum of the forces in the x direction equals ma, and that's all 0. So the sum of the forces in the x direction, my forces are acting sideways. Oops. Force of tension minus the force of friction. I go minus because it's to the left. So again, 0 equals the force of tension minus the force of friction. 0 equals 39.2 newtons minus the force of friction. Well, 39.2 minus what equals 0? All right, the force of friction equals 39.2 newtons. That's the third part of that problem right there. Because it's an equilibrium, acceleration is 0. We figured that out. So that's the third part of the problem. That's the force of friction. Now the next part, last part of the problem is what's the coefficient of friction? The coefficient of friction, the equation for friction. Friction equals mu times the normal force. The force of friction is 39.2 newtons. Mu is what we're asked to solve for, the coefficient of friction. In this case, it's the coefficient of static friction because the box is at rest. And the normal force is 49 newtons. Okay, well, you need mu by itself, so let's divide this side by 49 newtons. We'll divide this side by 49 newtons. Those will go to 1. 39.2 divided by 49, 0.8 equals mu. Done. Part 3, part 4, solved. All right, that's it. Good job.